See if All right, welcome everyone. This is our fourth and final session of the summer. In this one today, we are going to be talking about graphing related items, graphing on the coordinate plane, graphing linear functions. Like most of the things that we've been talking about, and most of the things in math in general, it builds off of something prior, right? It's rare that you're learning something that has no connections to anything at all. Most of that happens when you're in early elementary school. Um, you should have done some graphing in sixth grade, plotting points, maybe making a table of values, maybe graphing, a line using a table. But we'll expand upon that a little bit and get you ready for what you're going to encounter in Algebra 1 this year. So like I mentioned, this is our final session. There is not anything next week. Next Tuesday morning, you guys are off still, right? You don't start until Thursday, but teachers are going to be in, so I'll be in school. So this is our last session. There's nothing next week. The next time I'll see you guys after today would be in person on Thursday, September, what is that? My dates are all mixed up. September 5th. So after today, it would be the first day of school. I'll see you guys. Okay. If this is the first one that you're attending, first, not in person, but first live one that you're attending now, and you haven't seen anything else, I have been posting the recordings. I'm recording this one right now. We're 3 for 3 so far, so hopefully we'll be 4 for 4 in terms of the recordings, working out and everything like that. There did seem to be like a weird audio issue from last week's. I was watching the beginning. I don't know if something with my headphones. It just sounded a little weird, but hopefully if you were able to watch it, you got something out of it. So we have after today, we'll have four of these videos, 4 of these sessions that you could always refer to. And again, I'm going to repeat it for the 4th time probably. The purpose of these is to just give you a little bit of a head start. We're going to encounter all these things again. We're going to have individual lessons. It's going to be a little bit more normal because it's a 40-minute period. These are like an hour and a half, so it's kind of like a double period. And it's not going to be, a bunch of information condensed. Like 2 weeks ago, we talked about factoring. That was like a week of lessons in this one, Google Meet. So it's condensing things, it's reviewing things from last year while adding new stuff. It's just trying to give us a head start. This way, when we come in the first day of school, the first week of school that we're, doing lessons and things like that, it's maybe not as intimidating. Algebra 1 is a high school level math course. It's traditionally a 9th grade level course. You guys are going into 7th grade. So it can be a little overwhelming at times. I'm not going to say it's like this impossible class. Students do really well at it, generally speaking, but this is, an honors class, an accelerated class, whatever we call it, it all means the same thing. But early on in the year, sometimes it can seem a little intimidating. It can seem tough. It may seem impossible at first, but hopefully these summer sessions have eased your anxiety a little bit, and you're starting to feel a little bit more confident in terms of how the year is going to play out. Okay, I think I've kept this agenda pretty much the same, aside from just changing the topic. Solving equations. Maybe review. Okay. So I always like to start. I've been posting Delta Math assignments more so for the drill and practice stuff. We do some practice in our actual lessons itself, but let me just open up Delta Math as well. Delta Math is really what we're going to be using for homework, for sometimes in class, not super, not very frequently, but it's a great drill and practice website. Gives you feedback right away. Did we encounter any issues on Delta Math? See a good chunk of people got 100%. I always like to say, like, any weird questions that popped up, something you didn't know how to do, something you didn't know how to type in, question you didn't know how to do. Did we feel it was pretty straightforward? Any feedback that you guys could give me? Delta math was, go ahead. Okay, everything was fine, no weird examples. If you ever want to type something, one of the more common ones I get is like, how do you type in a fraction? Just hit the slash. It makes it into a fraction for you. So if I wanted to type 1/2, I would type 1 slash, and as soon as you type the slash, you get the little, it looks, like a fraction where you can now type on the top and bottom. So just hit the slash. That's one of the more common questions I get. Or I think even hitting the divide button works if you're on like an iPad or something. So if you hit the divide button, it gives you a little ratio. Okay, supplies again. We are going to be talking about the graphing calculator today. Not talking about it, but I should be able to share my screen and show you guys what that looks like, and go over some things, being that we're talking about graphing. So again, some supplies, notebooks and stuff. We'll talk about the first day of school. I don't really go crazy with that. I let you guys choose whatever you like. So whatever works for you. A binder, the old school, marble notebooks, I used to call them, like the black and white, or whatever color it is. Those are a little bit tougher if you want to like rip a page out, which doesn't happen very often, but keep that in mind. Or your, what do you call the other books? Any type of book works, regardless. Whatever system works best for you in terms of supplies. Things that you do need, the graphing calculator, your own graph paper, reason being homework, things like that. You don't want to be printing like templates. I posted a template on Google Classroom for today. If you want some quick access graph paper, that's obviously not sustainable, throughout the year. It's not like you're going to print 500 pages of that. So graph paper, your basic office supplies, pens, pencils, things like that. Today we are going to be talking about linear graphing, so we'll do a overview of that. Again, condensing a lot of stuff into one little session here. And I guess to start, we'll do a little review of solving equations from last week. We'll do like a little do now. Collecting your folders, what does that mean? Collecting our folders. Yeah, so you do need a folder for like, I don't give worksheets very often. Usually what I do for homework is I'll post a PDF on Google Classroom. Many people do end up printing it, but you don't need to. But yeah, having a folder is a good idea. I'm not sure what you mean by collecting them. Collected your folder for projects. No, so probably not. You mean like almost like a what do they call that? A notebook check or something? I know sometimes teachers do that, like they'll collect your notebooks or folders and see, like, kind of check up on your organization. They use the folder to store them. Okay, of like your homework or your projects? Yeah, we don't really do that as much as you get older. So no. I just say get a folder more so for handouts. We do have projects, but most of them are done on like a little bit of a bigger poster board, so it's not something that you could keep it. I know what you guys are talking about, like you have a project folder. But yeah, we just kind of move away from that as you get older. A portfolio, I think, is like what you guys are talking about, right? Yeah, not something that we do as you move past, sixth grade. Okay, let's do a little review. Let's pull up an example. Okay, so we'll treat this as a little bit of a warm up. Warm up, do now. I probably use those interchangeably, but they mean the same thing. I don't know what your teacher last year called it. Start, lesson starter, or something. They're all synonyms that mean the same thing. It's like how some teachers say aim. I say aim still. It's a little bit of an older word. Some teachers say teaching point. Some say learning objective. All means the same thing. So we talked last week, if you were here, if you weren't here, about solving equations. We'll treat this as just a little bit of a warm-up, and will kind of help us review as we go through the solving process of it. Not going to make it too crazy. Okay, that's good enough, I think. So copy that one down. We'll say solve this. We called this last week variables on both sides. Some of you said you did it in 6th grade, surprisingly. I think that works. Take a minute, try that as a little warm-up. And then we are going to be talking about graphing today. If you have your graphic calculator, if you have graph paper. If you don't have graph paper, you can quickly print the template that was posted on Google Classroom under session 4 for today. If you have an answer and you want to send it in the chat, feel free to do so now. Has anyone seen what the school looks like recently? If you're unaware, if you live further away, they are doing some construction. I know some of you guys probably live across the street and you see it every day, but they are doing some construction. So they do that thing where they put, it's called scaffolding all around it. Basically, it's just like a safety thing. I think they're doing the roof and some of the brickwork or something, but regardless of what you're doing, you have to put up like all these, safety stuff. The school is very different looking. Okay, let's take a look. So we said last week, when you have, generally speaking, it's tough to give generic steps for how to solve an equation. Like, hey, do this all the time. That was one of my first tips last week, right? I said, hey, I don't even really have we had some notes last week, but we don't have amazing notes because every equation is going to look different. Every equation is going to have its own, look to it, that it's hard to give steps that say, do this, do this. So generally speaking, what we want to do is clean up each side of the equation as much as we can. And then once we get to the stage where we can't do anything on the left any further, we can't do anything on the right any further, then we make the decision, hey, which side of the equation do we want to move the variables? Which side do we want to move the constants, the numbers? It does not matter. Some people choose the larger coefficient for the variables. Some people just say, I'm always going to move x to the left. It does not matter. But let's get to this. So on the left, we see a number outside or term outside of a parentheses. We call that distribution. I'm going to draw my two little arrows to remind me to multiply twice. 2 times 3x is 6x. 2 times -1 is -2. I have nothing to do on the right. I'm going to copy the whole thing down. We don't want to be too lazy, so sometimes people like clean stuff up and they're like trying to condense everything into without having to rewrite it. They're like writing it underneath the text or wherever it's printed. So we don't want to do that. Just takes 3 seconds, write it down. Even like in this case, the right side. I wouldn't like I said, try to manipulate what was printed. And now I'm going to combine like terms on the left. I have 5x and 6x. That's going to give me 11x. And I have -2 and -8. It's going to give me -10. So now I've reached the stage where there's nothing else I can do in terms of, cleaning up, condensing, combining like terms, distributing. There's nothing else I can do. Now I have to make the decision, where do I want to move the variables? Where do I want to move the constants? To be honest, it does not matter as long as you do separate it and you do it correctly. So I'm going to bring my x to the left. And being that I'm moving my variables to the left, I'm then going to move my numbers, my constants, to the right. Negative 10 plus 10 zeros out. 3x minus 3x zeros out as well. 11x minus 3x gives me 8x. And on the right, negative 34 plus 10 gives me negative 24. Okay, we're getting there. Now we have 8x. 8x equals negative 24. Last step, I want to get rid of that times 8. I'm going to divide by 8. Negative 24 divided by 8, we get a final answer of negative 3. We also said you can check equations by plugging it in. You can substitute in a negative 3 to your original equation, and if it is a true solution, it should work out. It should lead to a true statement. It should be something like 5 equals 5 when you plug it in. If not, you did make a mistake somewhere. Okay, I know we talked about other examples, but just one quick little review from last week. Questions with this one, or equations in general, or anything with the delta math from last week? We're good? All right, so let's get into graphing. Start our graphing connection. First thing that we're going to talk about is slope. Type in the chat or send a reaction. Did you talk about slope in 6th grade? Did you talk about slope at all? The word slope? A bunch of people saying yes. Okay, so slope is going to be an important part of graphing. One, it's an actual, topic. You could do questions where it's like, hey, find the slope, calculate the slope. But we also use slope for a lot of our graphing. For people that know what slope-intercept graphing is, that's one of the strategies we use. So it is important that we know what slope is, aside from just being able to calculate it or know what it is. Slope is exactly what it sounds like. It's one of those words where it actually exists outside of math, right? You possibly could have said it in some context, maybe even just another synonym of it. If you've ever been skiing or snowboarding or anything like that, you know exactly what slope is. A black diamond in skiing or snowboarding, very, very steep mountain, right? What are the not steep ones called? Greens, or like the little bunny hills, not very steep, a gradual or a low slope, right? So slope is a ratio of vertical change over horizontal change. Basically how steep something is. How quickly does it change vertically versus its horizontal change. Slope can be one of 4 options. It could be positive. Okay, think about like a business meeting, a stock market where something's going up, right? It's increasing from left to right. Slope can be negative. It would be like a business, something that's going out of business, something that's decreasing from left to right. Undefined is a vertical line. We'll talk about what makes that undefined. And a slope of 0, or zero slope, is a horizontal line. So we have one of 4 options for what slope can be. And what this means, when something has a positive slope, it means that when you actually calculate it, you get a positive value, you get a positive number. If I were to calculate the slope of that line in the top right, okay, it looks like it's just a slope of 1, but for argument's sake, I would get something positive. I would get, the slope is 3 for that line. I get a positive number. If I were to calculate the slope for the negative, the top left picture, I would get some negative number. So aside from just being called that category, there's actually, obviously a correlation to the number you get. So I would get -2, -1, I get some negative. Undefined is kind of like the error message you get in your calculator if you just start playing around hitting buttons. It means like we can't even do it. Undefined. Little 0 with the slash through it. Like, hey, you can't even do this. And 0 means we would actually get 0. If I calculated the slope of this line, we're going to learn how to, seems like many of you said you've done some basics with slope. If we were to calculate the slope of a problem like the bottom right, we would literally get 0. That's why it's called a 0 slope. Does anyone remember from their 6th grade what letter we use for slope? What letter do we use? And it's not S. It is not S. M. Very good. Very good. M. So we do use the letter M to represent slope. Common question that we'll get like, oh, that doesn't make sense. Why don't we use S? First of all, two very quick explanations. One, a lot of things in math goes without saying, but are not based off the English language. A lot of stuff comes from different cultures, different civilizations, thousands of years ago. So not a lot of stuff corresponds in that light. Also, you'd run out of letters pretty quickly if you just said like, hey, I'm going to use the first letter that this thing starts with. So S is used in another formula somewhere. Sometimes it's just a matter of, using something appropriately. Yeah, okay. One little trick that I always have for this, some of you that have siblings that have had me before don't know what this is. So it's just like a little picture to remember the 4 types of slope. So this is a negative slope. I put a little negative sign. This is a positive slope. I put a little plus sign. This is a undefined slope. I put a little U. And this is a slope of 0. Put little zeros. And all together makes a little scary looking guy. Just a way to remember your 4. Obviously, positive and negative are kind of hard to mess up. Just because we have so much, connection. Like I said, stock market, something going down, something going up, pretty self-explanatory. It's these 2 that people confuse. This little silly face does help. A vertical line is undefined, whereas a horizontal line is 0. Those are 2 different things. Over the years, we've called this guy Mr. Slopey. Some students have told me they're afraid of Mr. Slopey, but ends up being like a class mascot of sorts. Has anyone seen this before? If you switch the order of his 2 eyes, he starts to look a little depressed. Mr. Slopey. Okay. Has anyone seen that before? No one's seen Mr. Slopey? Okay. 6th grade teachers don't teach Mr. Slopey, I guess. Okay. Tough crowd. All right, how to actually calculate slope. Okay, this is your slope formula. We're not going to end up really using, this is like what would be in a textbook, right? Y2 minus Y1, X2 minus X1. These are not exponents, first and foremost. Those are not exponents. That does not say Y squared. These are what we call subscripts. Subscripts are, subscripts are, instead of being in the top right, they're in the bottom right. And it's basically just a naming capacity. Okay, it's saying like, hey, the second X value minus the first X value, because we're using X twice here, right? It's like when you make a copy of something on your desktop and you don't change the name and it just adds like a 1 after it, and then it adds a 2 and adds a 3. It's the same idea. So it's just a naming capacity. Okay. And I'll show you, so this is, like I said, it's the slope formula. I'll show you how I like to do these problems. I always find that the slope formula, especially for people that are new at it, can be a little confusing, can be a little tricky. So it's nice to have another approach, another way of looking at it. Okay, so let's just kind of zoom in on one here. It says, first question, what is the slope of the line that passes through the points -1, 2 and 5, 26? Okay. So what I like to do is, and I'll explain why, because it's going to seem kind of random at first. I like to make a table. an XY table. Doesn't take very long. It doesn't have to be perfect. I'm not going to take out a ruler and make a perfect table. So I quickly take those two coordinates. Quick little review. If you forgot, with coordinates, first number represents X, second number represents Y. Excuse me. Alphabetical order applies here. Alphabetical order is a nice way of remembering that in case you did ever forget. Why I like to do a table is I find that people tend to make a mistake when they just see it like this. It's very, very easy to switch what's X, what's Y. Sometimes your brain does it maybe subconsciously, just looking at it quickly. It's a lot harder to make that mistake when you have it in a nice table. And it didn't take very long. I see it all the time, even, students that are comfortable with it, they'll do something like this, and they're looking at a Y and an X value instead of two Y values, right? So a table just kind of makes it neater, makes it cleaner, eliminates those silly, quick mistakes. Okay. Now we define slope as M. You could write slope or you could say M. It's the change in the Y values. In math, a symbol that we could use for change is a little triangle. A little mini triangle. Here's my AirPod. And another little mini triangle. Okay, we call this delta. Delta in math just means change. That's a quick fancy way of saying the change in the Y values, how much are you changing vertically, divided by how much are you changing horizontally. Okay, change in Y over change in X. So looking at our Y values, this is what I tend to do. Remember earlier I said like, oh, there's a formula and some people use it, but I think it's more so just looking at numbers and doing some arithmetic. You don't have to like think of it as, hey, let me plug into this formula, let me do this. How much are the Y values changing here? We're going from 2 to 26. Let's look like top to bottom. So we're going from 2 to 26. How much am I changing? I went up 24. If I was really confused about that for whatever reason, and I feel like I couldn't do it in my head, maybe there's larger numbers, maybe there's some decimals or fractions, what you're really doing is the formula. You're doing the second value minus the first one. That's what I mean. It's almost easier to do it mental math than to think of it as a formula. And now let's look at our X column. We're going from -1 all the way up to 5. From -1 to 5. What is that as a change? What's the change? What's the difference between -1 and 5? 6 plus 6. So people confuse the signs sometimes when they first start doing this, right? You'll say -6. But again, think of it as top to bottom. Obviously, I increased. I went from a negative to a positive, and I went up 6. Okay? Again, if I was really confused, I could use my calculator. I could do something like this. Hey, what's the difference between the bottom number minus the first number? It is important that however you look at it, that you keep it synced. What I mean by that is I looked at the top row down to the bottom row when I did this. Okay, when I did Y. I wouldn't then like switch it for X. What I mean by that is even when we're doing mental math, I said, hey, you guys, if you go from 2 to 26, what is that? I wouldn't go over here and then say, all right, now I'm going from 5 to -1. So whatever order I start doing this problem, I want to make sure that I'm doing it the same for X and Y. Okay, and last but not least, our ratio is 24 over 6. Like most things, we can simplify it, and we can just say the slope of this line is 4. If you don't like this table way of doing it, again, obviously, you could just, jump into the formula. Say y2 minus y1, x2 minus x1, and you get the same thing. I like to show it this way just because I think it's a little bit cleaner to see. It's a little bit nicer to see. It'll, like I said earlier, helps eliminate some of those mistakes that people make just kind of flying through it. Is the math very difficult? Is the arithmetic very difficult with these? No. So we don't want to make an error, subtracting two numbers or something like that. Questions calculating slope. Questions calculating slope? why don't you guys try this one quickly? Try this one. And again, you can do this however you like. If you had your own way of doing it, I'm not sure. Some of you mentioned that you did cover it this year. However you'd like to do it, it's up to you. See how we did? So, again, I'm going to make a quick little XY table. Doesn't take very long. I'm going to look at this as a vertical over horizontal change. So change in Y first. I always like to write this. Another mistake that people make with slope, right? Anytime you're doing something with two options, people confuse which one goes where. So it is always Y up top. We say Y to the sky is a little trick. However you want to remember that. Change in Y over change in X. So here, I always go top to bottom. So I'm starting with 5 and I go to -3. That as a change is -8. Basically, you went down 8, right? You had $5 and then you owed someone $3. You lost $8. 5 to -3. If you did get confused and you wanted to do it as subtraction, you would say -3 minus 5. If you had trouble doing that in your head, mental math wise. Second one, if you're looking at -1 to +3, the change there would be +4. Okay, doing that in your head would be 3 minus -1, which is how we get the 4. Putting these two together, we get -8 over +4, which gives us an answer of -2. The slope of this line is -2. How did we do with that one? If you're more of a slope formula person, again, I'll show you what it looks like. -3 minus 5 over 3 minus -1. Get the same thing. I'm just showing you a different approach. I find that the table is more helpful, but it is ultimately up for you, up to you. Okay. Quick question. Earlier we talked about, or quick little point here, we talked about the types of slope, right? So this was a negative slope. We got a -2. This would be a line that's looks something like this, right? It's decreasing from left to right. The two what do you want to call them? The two less common examples, undefined and zero slope. Let's talk about those. Why are they called that, right? Excuse me. So let's start with the vertical line. A vertical line, sometimes people forget what vertical versus horizontal means. We said this slope is undefined. Undefined and zero are not the same thing. Undefined means like, hey, you can't even calculate this. You can't even do this. It's like an error message when you're trying to do something on your phone or your calculator, right? In math, the symbol for undefined, you could do something like this. So why is it that? Why do we call it undefined? If you were to do slope, I'm just making these numbers up. Let's say this was, something that we could calculate. Yeah, it's basically related to that. You run into a divide by zero error. Let's say that this is, I don't know, just making values up. This is 2 and this is 4, right? We have a vertical change of 2 here. We don't have any horizontal change. If I had coordinates, let's say my coordinates were 1, 4 and 1, 2. So our vertical change was 2. Our horizontal didn't change at all. It went from 1 to 1. So the change was 0. And what's the problem? If you were to type that into a calculator, if you're trying to figure that out, we have a divide by zero error. So that's why we call a vertical line undefined. On the flip side, a horizontal line has a slope of 0 because now we have a horizontal change, but we don't have any vertical change. So 0 divided by anything is always going to be 0. So those are our two special cases and why they're kind of locked into those choices. Whereas positive and negative could be any positive number, any negative. Undefined is always going to be undefined because you're dividing by 0. A horizontal line is going to be a slope of 0 because 0 divided by anything is going to be 0. Okay? Just wanted to show you the two weird cases, I guess, if you want to call them that, with slope. Okay. Related to calculating slope, you don't need to write these down unless you really want to. Related to calculating slope, sometimes we're going to be given an image, a picture of a graph, and we may want to identify the slope that way. Okay, just working with the graph. Obviously, one option for doing this is, and this wouldn't be a great one, but you can make it into like the problems we were just doing. You can say like, hey, I'm going to write down the coordinates. I'm going to write down the coordinates, do the table, do the way, slope formula. However, if you're given a picture of a graph, you could use the graph to your advantage. You could just basically count on the graph. First thing that you're going to do is identify 2 nice points. What do you think I mean by nice points? Nice is in quotes there. Not a technical term. What do you think I mean by nice points? Here they're very obvious, but sometimes they might not be. What do you think nice points refer to? Yeah, something that you could clearly see on the graph. Right? Here you actually see like a bolded dot. Sometimes that's given to you, sometimes that's not. But even if those dots weren't there, let me see, it might be a little blurry, but I'll show you a non-example to make more sense of this. Like if you guys could see a little red dot. This is not a nice point. I know that its x value is 2, but do I have any idea what this y value is? I'd be guessing, right? I'm like, oh, maybe it's like a half, 3.5. Do I know exactly what it is? No. Even this point right here, see that little bit of space? I know that it's not 3, but I have no idea what it is. Is it 2.9? Is it 2.8? I don't know what it is, 2 3/4. So there's a reason there's a dot here. It hits exactly in the corner of your graph paper. So even if this dot wasn't here, I know this is exactly, what is that, 4? I know this is exactly 2. Okay? That's what we mean with a nice point. Now the step says, start with the leftmost. That's easy to remember because that's how we read. Some cultures do read right to left, but we read left to right, right? So we're going to start on our left and work our way to the right. We're going to count the rise. Hey, how much do I have to go up? How much do I have to go down? If you move down, your rise is negative. You're then going to count the run. How much do I have to go left to right to reach that point? If you're starting on the left, you should be going to the right, but yeah. And as a reminder, because I don't think we phrased it this way, slope, we said change in y over change in x. Another thing that you hear a lot is rise over run. Sometimes I like to misspell the word rise, just as a reminder that y goes up top here. So walking your way through this, I'm going to start at this point, and I'm going to count how much, in this case, I need to go down to get on the same level as this point over here. I need to go down 1, 2, 3 boxes. So I'm going to say my rise is -3. I'm going to like illustrate the counting. Obviously, you would just physically count. But this is where a -3 comes from. Why am I saying -3? Because I'm going down. If I were to say 3, that's confusing. Like, did you go up or down? So the negative gives us a sense of direction. Negative if you go down, positive if you go up, or, it's like increasing versus decreasing. Now, your run is always going to be positive because we're always going to be running to the right, being that we started on the left. So I'm right here right now. How many boxes do I have to go to the right? Let's count. 1, 2, 3, 4. So my run here would be 4. Putting these two together, the slope of this line would be -3/4. Okay, moral of the story, if you have a picture of a graph, it does tend to be generally easier to work with because you're more so just counting instead of doing any arithmetic. The only real mistakes people can make would just be making a mistake counting, so do so carefully. Use, if you had this in front of you, use your pencil just to make sure, or forgetting a sign, forgetting a negative. This does make sense that we got -3/4 because just visually zooming out and looking at it, this is a negative sloping line. Right? If I put +3/4 and then I looked at the line, I would almost doubt myself like, hey, wait, shouldn't this have been negative? Questions with calculating slope from a line, from a graph. We're good? Okay. We're not going to do all of these, so let's see. Do like a little mini practice here. We are going to do graphing. If you're like, hey, I thought you said we're doing graphing. Why are we? It's important that we know how to do slope before, you got to learn how to walk before you learn how to run, type of thing. So let's do this. I don't want to go too crazy here, take too much time. We'll do 5 problems. How about that? I'm crossing stuff out, just a quick. So let's try A, B, and C. Number 2 there, and we'll get rid of this. We'll just do 4. So A, B, and C, and number 2. You can take a little mini break here. We're about halfway through. If you want to grab something to drink, take a little break. We'll say it's 9:46, like 9:50. We'll come back and take a look at how you do with this. We will be doing graphing. This is graphing related, right? Slope. Promise we're doing physical graphing right after this. It's just important that we have slope down first. Take your time. 9:50. I'll be back on. If you have any questions, type them in the chat as you're working. These 3 problems that you can see, 4 problems that you can see: A, B, C, and number 2. All right, welcome back. So let's take a look at how we did. Um, for 1a, we had -2, -1, and -8, 17. If you want to type in the chat, what did we get for the slope for a? We'll just kind of cut to the answer to save some time here. Did anyone get 1a? -3, very nice. Your y change would be 18. Your x change would be, your change in x, would be -6. 18 divided by 6, 18 divided by -6 would be -3. Okay, for b, what did we get for 1b? -2. So here we have 10 minus -12, which is 22. I guess maybe we'll spell out the work a little bit. 22 over -5 minus 6 is -11. This should be -2. Okay, and 1c. What did we get for 1c? -15.3 and 6.3. Did anyone get up to 1c? What did we get? 0. Yeah, just slope is 0. Your vertical change here is going to be 0, which means regardless of what your horizontal change is, if it's any non-zero, it's just going to be 0. Be careful if you said undefined, that would be if the x values were the same. So generally speaking, how you could spot these weird cases, if your y values are the same, you know it's going to be a slope of 0. If your x values are the same, you know it's going to be an undefined slope. Okay, good with those three. Now, 2 is a little bit of a different approach. We're given the slope and we want to find a missing coordinate here. So we're told the slope is 3/2. Slope, I think the ones we've been doing for the most part have been integers, but more commonly it's a fraction. Slope of 1/2, slope of -3/5. So the slope here is 3/2. We want to find the missing value. Did anyone find the missing value here? Did anyone find the value of k that would make this work? The slope between these 2 points is 3/2. What's the missing value of k? It's not 1. Also not. Okay, so yeah, let's take a look. Because this is a little tricky. So a few things you could do here. Let's think about making a table. First of all, k is, don't get too confused, just representing some unknown. It's the same as if we just kept it as y. So let's put in our 2 values. We have 5k and 9,4. We could see that we don't know what the change in y is. Something to 4. I can't calculate that. But I could see the change in x is +4. Which, let's think of this as a ratio. We're told that the simplified slope is 3/2. When we did our table, we see that it's +4. So we're not going to have that direct line of, x was +2, which means y was +3. That's why I think someone said 1, which is a good guess, a good attempt. Here, what's the equivalent of 3/2 as something over 4? It would just be 6/4. Okay, do we all agree? 3/2 is the same as 6/4, which means I know that the change here is +6. Again, why am I saying 6/4 if you told me the slope is 3/2? They're equivalent. It's just that the change in x was +4, so I had to make it an equivalent fraction. Okay, I know it's +6 even though I can't calculate it. So what number got 6 added to it and ended up with 4? -2. -2 plus 6 will give you +4. And if you want to walk through it now with knowing that it's a -2, you will get 3/2. Simplify. You'll get 6/4, but you can simplify that to 3/2. Very good. Okay. A little bit of a, what do you want to call that? More abstract solving one. Okay, let's get into, I'm going to skip around a little bit. All right, here's where we're actually getting into graphing. I promised we were getting into it. Here it is. So one of the major techniques that when you first start graphing, you guys this year might have done some, did you do any graphing lines in 6th grade? Did you fit aside, I know you did plotting points, that's a 6th grade standard, but did you actually graph lines? So one of the ways that you start graphing lines is making a table of values, right? And you eventually get to this. This is how we graph line, not saying that making a table is bad or anything like that, but slope intercept, mx plus b, I think everyone's heard it subconsciously. You've seen it on a math poster in a math classroom. Mx plus b, slope intercept, is ultimately how we end up graphing lines. That's why it was important that we understood what slope was. If you don't know what slope is, it's going to be difficult to apply. The intercept part of slope intercept form is not that crazy of a word. It's just the y-intercept, which is the point where the graph hits the y-axis. Kind of in the name itself, right? What's the y-intercept? It's where the graph hits the y-axis, the y-intercept. Okay. In mx plus b, we've already talked about the idea that slope is m. So the number in front of x, the coefficient of x, is going to represent our slope. And that number on the end, another kind of weird letter to naming aspect, the y-intercept, we use the letter b. That's going to be whatever the constant is on the end. It's at the bottom here, a very, very important aspect of this method or style of graphing is the fact that this only works when it's in y equals form. Okay? This strategy, this style of graphing, notice in the top up here, okay? This only works when it's in y equals. I put an example down below. I wouldn't be able to look at that and say like, oh, the slope is 3. Because he said whatever is in front of x is your slope. You can only identify slope and y-intercept when it's in the form of, we say y, you're going to hear me say y equals a lot this year, right? Only when it says y equals. So if I got it to look like this, then I could use this strategy. I could identify the slope and y-intercept. I could use it to graph. We're going to learn how to use it to graph on the next slide or two. But important that we identify that first. Sometimes you're given something that's nice and already, ready to go. Okay, y equals 2x plus 3. Okay, the slope is 2, the y-intercept is 3. Great. More commonly, you're given something like on the very bottom here where you have to do a little bit of work first. Okay? So we'll talk about this and we'll practice with this, but how you can get this to look like y equals. It's not just like, oh, all right, we can't do anything. It's not y equals. You can manipulate this. You can change this. So what you would do is, it's good that we did solving equations last week. I would move this 3x over to the right. 3x minus 3x is 0, cancels out. I get 5y. Be careful, I cannot combine these. Don't say 10 minus 3x is 7x. That's going to be negative 3x plus 10. They just basically go side by side. I do like to put the x first. It wouldn't be wrong to say 10 minus 3x. I just like to kind of squeeze the x in first. And now I'm closer. Now I just have to divide everything by 5. So negative 3 divided by 5, I'm just going to make that negative 3/5. And 10 divided by 5, I'm just going to make that 2. So I put them next to each other. What I just boxed in and what was originally printed in black text are the same equation. What was the purpose of me messing with it? Now it's in y equals form. Now I can use this strategy. Okay, now I could say to myself, hey, the slope is negative 3/5 and the y-intercept is 2. and we would apply the skills that we're going to cover in a few seconds to ultimately graph this. Okay? I'm skipping around a little bit. I want to make sure that we get enough graphing practice and we're not just... Okay. So what we'll do this example together. So we're going to graph this, the equation on the bottom of this slide here, 3y plus 4x equals 9. We're going to do it together. I have some steps here, a little word association. If you have graph paper, if you have the template, we are going to physically graph it. If you don't have anything, you could just kind of watch here. And then what I'll do is, it's going to be a little bit of a delay because I'm on my iPad, but I'll switch to my graphing calculator on my computer. I have an emulator. And what I'll do is kind of show you some of the ins and outs of the calculator. Okay, we're moving a little quick here. I'm skipping over a few things, but I do want to make sure we get to a little bit of everything. So let's talk about the steps first, and then we'll do this example. It says plot the y-intercept. That's the b value. A way to remember that, b is where you begin. No, that's not why they use the letter b, but it's just a little memory device, a trick, whatever you want to call it. Slope is going to tell us how to move. Slope is going to tell us how to move. We're going to use the slope m to determine how we move. Hey, how do I go up and down? How do I go left and right? Again, word association, trick. It's not an actual thing. It's not why they use the letter m. We're then going to apply this as many times as we need. Using this strategy, you can plot 50 points, or you could plot 2 or 3 points. 2 points is a minimum for a line. I usually like to go a little bit over that. Makes it easier to connect. We use rulers when we're graphing formally in person. I have little mini rulers that you could always use on tests or during class. We extend the graph throughout the grid. So we trace our points with a ruler, and we place arrows on the end, and we label our equation, our line with the equation. Just a good habit to get into now. Okay, so let's dive into this. First thing we need to do, let me quiz you guys here. Can I just do this right away? Can I say, hey, the slope is 4? He told me earlier the slope is what's in front of x. Can I do that? No, I cannot. Why not? Can anyone tell me why? Y is not isolated. Yeah, a better name than saying mx plus b would be like making sure you say the y equals part of it, right? It has to be y equals. You can't just dive into something head first. So let's get y by itself. So I'm going to move the 4x over. Again, numbers and variables don't combine, so 9 minus 4x is not 5x. They stay separated. And I usually like to squeeze the x in first, just a more formal way of writing it. 9 minus 4x or negative 4x plus 9 are the same thing. I usually just like to put x first. Usually the variable comes before your constant. It's not wrong if you say 9 minus 4x. Now I need to get rid of the 3 in front of the y. So I'm going to divide everybody by 3. 3 divided by 3 is 1y. Negative 4 divided by 3 doesn't simplify, so I'm just going to leave it as negative 4/3. And 9 divided by 3 is 3. Now, work-wise, all I need to do is just write down m and b. There's no table, there's no major... That's the nice thing about this strategy. So my slope here is going to be negative 4/3, and my y-intercept is going to be 3. That's my key for all, I'm pretty much done. Now I'm going to jump into the graph. Pause for a moment. That's it. So after getting it into, that's the nice thing about this, is why it's a lot quicker than other strategies. Once you get it into Y form, you're pretty much done. Okay, now on my graph paper, it's labeled. So notice you have a y-axis, you have an x-axis. A lot of times starting out with graphing, we get questions because it's I think when you look at graph paper, when you work with graph paper when you're a little bit younger, maybe number lines, people want to do this. I see this like the first few times I hand out graph paper. People sit and they label every single box. We don't do that. You just leave it empty. You do have to count, which is a little annoying, but yeah, we don't label and stuff like that. Just leave it. We always assume that one box is one unit unless otherwise noted. Usually when we're doing like word problems and stuff is where we'd set a scale where the boxes, represent something different. So let's go back to our steps now. We're going to plot our y-intercept. This is where we begin. Our y-intercept is 3. Keep in mind the y-intercept does have to be on the y-axis. So I'm going to plot a point at 3. Okay, very common mistake that people make. They plot their y-intercept on the x-axis. So y-intercept goes, I know it's self-explanatory, but it does happen a lot. Y-intercept goes on the y-axis. That's always going to be your first point when you graph. If you had a negative y-intercept, it would be, somewhere down here. Let's say it was -3, we would have plotted a point right here. Positives up here on the y-axis, negatives down here. If your y-intercept was 0, you'd be right at the origin. Okay, now this is the tricky part. Slope is going to tell us how to move. So if I have a slope of -4/3, how am I going to move? How does that make, if someone asks me directions, would I just say -4/3? What does that mean? -4 is going to indicate to us that we're going to go down 4, down because negative, and the denominator being 3 is going to indicate to me to run 3 to the right. I should say right. Okay, so that's how that number kind of translates. Hey, down 4, right 3. And I could do this multiple times. So starting at where I put that purple dot, I'm going to go down 4 and right 3. So 1, 2, 3, 4. I don't want to do this. Some people they put a little slash. Don't just hold your pencil, your pen above that. So down 4. And right 3. And then once I do both of those movements, I put a second dot. Again, I'll do it now with the laser. 1, 2, 3, 4, down, right 3. 1, 2, 3. Once you do both of the movements, you put a dot. And I could do this again and again. Down 4, right 3. Down 4, right 3. So squeeze in another one. It's always easier to have, more than the bare minimum. Bare minimum is 2 points. Technically, you can make a line with 2 points, right? But the more points you have, the easier it is to make a nice straight line, the easier it is to trace your ruler. If for some reason I wanted points up here, and you're like, hey, maybe it's a case where you can't fit anything on the bottom right-hand side. It's some, large number, something like that. If you want points in the other direction, you could do the exact opposite of the movement. So instead of going down 4, right 3, what would be the opposite? Because we're trying to backtrack. What's the opposite of going down 4, right 3? You can go up 4, left 3. That would be like figuring out what the point was before this. Okay, I can only fit 1 up there because if I go 4 more up, well, standard graph paper is going to be 10 by 10, so I can't fit anything else. And once I have those points, I would lay my ruler down so it's kind of like slicing them in half. I have a little line tool on my iPad, so a little hack. But what I mean by slicing it in half, see how this point right here, the line kind of goes right through the middle of it. It doesn't have to be perfect. We're not going to look at it like under a magnifying glass. Like you can see mine's like a little bit off there, but perfectly fine. We don't want to freehand our lines. So you never want to draw a line where it looks like, a Richter scale. So that's why we use rulers. Even if you think you're neat, it's very, very difficult to draw a perfectly straight line freehand. So we use rulers to trace them. Why do we put arrows on the end? That was in the notes, but we didn't talk about that. Does anyone know why you put arrows on the end of your line? And labeling is a good habit to get into now, particularly when we get into systems. It's technically not required, but labeling is just a good habit to get into. Why do we put arrows on it? Yeah, it goes on forever. Does this pattern, does this equation ever end? No. The line is infinite. It's a way of saying, hey, this relationship, this equation continues on forever. Here's a little snippet of it. Here's a little, 10 by 10 section of it, but it does continue forever. Okay. Now, what I want to do is how should I do this? I'm going to switch out of my iPad. And for people with calculators, if you want to grab one, I'm going to show you guys. Can everyone see, it looks like a graphing calculator? Okay, cool. How many people have a calculator in front of them? Bunch? Good amount. Okay, if you don't, it looks something like this. Okay, the screen's a little bit larger so you can see. So what we're going to do is show how you can graph on this calculator. Now, obviously you do need to know how to graph by hand. Unfortunately, these calculators don't come with like printers on them. So no, you can't just tape them in and get a little Polaroid that comes out of the back that you could do for homework or on a test. So they're called graphing calculators. They help us with a lot of things, but you do still need to know what we just did, which is graph a line by hand. It's my dog, sorry. So what we're gonna do first, in the top left, we're gonna hit the button that says y equals. Just give me one moment, I just have to let my dog out. So hit the y equals button. Sorry about that. And you'll get a screen that looks like this. Again, I hit the y equals button in the top left. It's red right now on the calculator, and you get this screen. Notice on this window, it's another good reminder of what we were talking about earlier, you can only type in y equals. The 1, 2, 3, are just like different equations. That's just a naming capacity again, subscript. These are different equations we could type in. You can only type them in y equals form. So that's going back to what we talked about earlier with y equals being the way to graph. Another connection here. So the example, what was the example that we had earlier? Hold up. We had was 3y plus 4x equals 9. So I can't type that in here. I'd have to type in the one that we made, which was the negative 4/3 x plus 3. So I'm going to go ahead and type that in. What I'm going to do is the negative button is next to enter on the very bottom. Do not use subtraction to mean negative. So negative is down below next to enter. Subtraction is, your normal for operations. So you can't use negative and subtraction to mean the same thing. A lot of times, especially early on, because I think the other calculators, the TI-34s, you can use subtraction to mean negative and it treats it okay. Here you'll get an error message if you try to say subtract. That doesn't make any sense. So negative 4/3, so 4. I want to show that. Okay, hold on a sec. So I'll go over how I just did this. Or you could see the buttons down there. So if you want to type in a fraction, there's two things you could do. I was going to just do it. If I were to just type in negative 4 and then hit the divide button and then hit 3, that would be recognized as negative 4/3. Because that's technically what that means. If you want to type it where it actually looks like a fraction, if you want to get that look that I have on my screen right now, you could hit alpha. The alpha button is the green one on my screen. Yours is probably a different highlighted color. And then hit y equals, and you'll get a little pop-up that will say ND. That means numerator, denominator. In other words, it's going to give you a blank fraction. And now you can use the little arrows to type in the top or bottom of your fraction. Now we want the variable x. X is right next to alpha, so just hit that once. Okay, and what was the rest of our equation? Plus 3. So I'm just going to type plus 3. Okay, I'll pause here for a moment. Did anyone have, people at calculators, have any issues with typing in so it looks like that? Did we have any issues typing it in? No issues? I like to have this template because a lot of times when I'm like demoing something, it's difficult to do if we have 30 people in the class. I'm trying to, explain this new feature on the calculator. Some people get stuck in a different spot and like, oh, mine's not working. It's helpful to have it in front of you rather than just talking about it. Also, you can see like the key press history. That's helpful too. All right, now what we're going to do, you probably could have figured this one out. We're going to hit the graph button. The graph is in the top right. You hit graph. You'll see a line that looks just like the one that we plotted. There's not arrows on the end, but it goes to the edge of the graph, so it does go on forever. That's our graph. Like I said, it's one, it comes out kind of pixelated. You don't get the full coordinate plane. It's a little difficult to read, but it does give you an idea of what your graphs look like. Another nice feature, if you wanted a table of values for this equation, maybe you're doing some sort of follow-up for it, you're looking at other things, kind of like the application practice question that we saw earlier, you want to know some of the x and y values of this equation, whatever the case may be. If you want a table of values, do you guys see above the word graph, above the graph button, it says table? To access that, you don't just like hit it again because that's just the graph button. Kind of like shift on a keyboard. Like if you want an exclamation point, you hit shift and then 1. You have to hit the second button. You don't have to hold it down, just hit it once. So hit second and then graph. See how I get that little arrow? It's kind of like shift. So now if I hit graph, I get a table of values. And this table goes on infinitely. You could scroll up. I got a nice little XY table of values. If you want to get out of the table, if you're ever in a screen and you don't know how to get out of it, right? That might be a question that you have right now, like, all right, how do I get out of here? If you hit clear, it doesn't really do anything. So if you want to get out of something, see where it says quit on my screen above the word mode, right next to second, there's a mode button, and above that it says quit. If you hit second mode, it's kind of like Xing out of something on your computer or hitting, Alt F4 on your computer, just like gets out of that window. And now we're just on the home screen of our calculator. Some other quick things on the calculator. What else could we cover? Exponent button, just like I think you're used to this. I call this a caret above the division sign. So exponents, we have a squared button over there above log. What else did I want to cover? Fractions and decimals, things like that. If you have some decimal on your screen and you want to make it a fraction, you hit math, enter. The nice thing about that is it will always reduce it for you. So when it gives you it in fraction form, it will give it to you simplified. So you kind of have a built-in way of simplifying fractions. There's a lot of things on here. I'm just doing a quick little overview now. Yeah, I don't want to get too much into it. Again, second mode if I'm ever on a screen and I want to get out of there. If you want to clear out your home screen, just hit the clear button. We have our parentheses. Again, important things, using negative early on instead of subtract. That will get bounced back as an error if you do mess that up. We don't use the trig functions until you get into algebra 2 or a little bit in geometry. So next year you guys will be dealing with sine, cosine, tangent, but for now we don't really dive into those. We'll be using a lot of the stat features this year, using lists and things like that. But yeah, for now, that's some of the basics. And now if I go back into y equals, and let's say I'm doing another example, you just hit the clear button. It wipes out everything you typed in. You can play around with this a little bit if you have a calculator, type in different things, see what it looks like. You could type in multiple equations. Sometimes that gets a little confusing if you're typing in like a bunch of different equations. The newer calculators, that's what I meant earlier a few weeks ago when I said like, there's more color with these. The old school calculators like mine in high school is just black and white. Now, you could see, oh, this one's red and this one's blue and the next line is black and then pink. So there's a lot more like color features. That's really, aside from it got a little skinnier as well. It's really only some of the differences with the newer models. All right. Questions with the graphing calculator? If you want to mess with the zoom, hit the zoom button once, and now there's a bunch of options here. You could zoom out. So if you hit 3 and hit enter, your graph will zoom out every time you hit enter. See, it's getting more and more zoomed in. If you want to make it normal again, a 10 by 10, you hit zoom. You hit zoom and then 6. Zoom 6 makes it like back to a normal looking graph. Okay, we'll be doing a lot of, demoing with the graphing calculator, showing you guys different features, different things you could do on here, different, it has a system solver. I just quickly did it. I don't want it, it's a lot to digest. So a lot of cool features on here, a lot of things, it justifies why it's expensive. Like I mentioned, this is the last calculator you'll ever buy. It's $100 and something, but you use it all through middle school, all through high school, all through college. And it has a lot of fancy features on here. I'll also show you guys some things that are technically not part of Algebra 1, but that can be used to help us with Algebra 1. For example, matrices. Matrices are something you don't learn until you get into like pre-calculus. So way down the line, 10th, 11th grade, even like college level classes, you work with matrix, doing some matrices stuff. For our purposes, matrices can help us solve systems if we know how to use some of the functions in here. And we'll learn how to do that when we get to systems. So like sometimes we could hack different things, not that it's cheating or something like that, but like, hey, this feature on our calculator, even though I'm not going to really learn what it is until like 4 or 5 years from now, there's a way to manipulate it or use it so it could help us with some of our applications this year. Like I said, systems of equations and matrices kind of work nicely together. Okay. I know today was a little bit of all over the place. We did some slope calculations. We did some graphing lines. Let's do this. Any calculator questions before I X out of that? Good with calculator? It's always tough with these meetings too. An hour and a half sounds like a lot of time, but I feel like it really flies by. So much to do. Okay. So we'll do one last example. Oops. We'll say graph this equation. Okay. If you have graph paper or grid in front of you, graph it by hand. And then once you're done, if you have a graphing calculator in front of you, if you want to practice with what we were just doing on there. Again, graphing calculator is mostly or I should say, for the most part, a resource to have. It's not going to like do an entire problem for you. So it's important that we a lot of times we'll learn a cool feature or something that it can do or this function on there, and don't misinterpret that as like, oh, okay, I'm going to tune out when he's explaining how to do this algebraically. It's important that we still know how to do these things. We're using the calculator as like a secondary tool, like, hey, let me check using my calculator. Hey, let me try it this way now with the calculator. This will be our last example. Like I said, time flew by today. Again, no meeting next week. Our next meeting will be the first day of school. First like 2 days of school. We don't really start lessons till like that first full week. Do some like introductory activities. We go over the syllabus. Yeah. Someone just asked, are we going to review? Iris just asked, are we going to review how to use the calculator when we start? Yes. So we don't have days where we're like, hey guys, we're going to spend the full period today, going over the calculator. For the most part, what it looks like is like today, for example, let's say we did a lesson on how to graph a line. I would take 5-10 minutes and be like, hey guys, here's just how you do, the line on there. So it would be difficult to explain every single feature on the calculator. So we do bit by bit. So like, hey, here's how you do this specific thing today, as well as, some of the basics. Hey, this is how you get out of a screen. Little things that, it sounds silly, but you don't know how to, some people don't know how to do is the first time they use it. Hey, make sure to use negative instead of subtract. So the basics I always talk about. The specific features we do like piece by piece as we do our lessons. Okay, how to graph this? First thing I'm going to do, I have to get it in y equals form. So I'm going to move the 2x over. Okay, 2x minus 2x zeros out. I get 5y equals negative 2x minus 10. And now I'm going to divide both sides by 5. I get y equals negative 2/5 x. Negative 10 divided by 5 is minus 2. So I say my slope, my m value is negative 2/5, and my y-intercept is negative 2. Okay, important that you note the negatives there. You wouldn't want to say the y-intercept is 2. It does say subtract 2, which for our purposes is the same as a negative. Now on my grid, since my y-intercept is negative 2, my first point is going to go here. Remember, y-intercept, y-axis. And my slope is negative 2/5. So how am I going to move? I'm going to go down 2. I'm going down because it's negative, and right 5. You're always going to go to the right. The only thing that's going to change is you going up or down. And again, you'll go down if it's negative. I'm not going to be able to fit many points here. Remember, we said if you want points in the other direction, do the exact opposite. You can go up to left 5. You don't need to, but just to show you here. And now you would lay a ruler down and trace over them. A good thing with lines is you kind of know if you messed up, because if they're all over the place, you messed up. So if they don't form a straight line, you made some sort of mistake with applying your slope, maybe counting or plotting. If it's coming out like a connect the dots, not straight line, you made some sort of mistake. We put arrows on the end, and good habit to get into is just labeling it with the original equation off on the side somewhere. Labeling it as a way of saying like, hey, this is what this is. Okay. I'm going to pause the recording here. I know that was